This will be 10th lecture. May I ask you what we learned in the last lecture? Anybody can remember what we learned in the last lecture? Okay, we learned in the last lecture 3 symbols. One is star and moon, and the other one was sun. Okay. Each symbol has its own characteristics. For example, this one is Newton's law, saying resultant force will induce motion. Therefore, I could say if the problem you have associated with force and acceleration, then it will be an appropriate tool to tackle the given problem. And this one associated with momentum and impulse, that's why we call it principle of impulse and momentum, will induce change of momentum. Okay, symbolically we could write so linear momentum at state 1 will be changed by applying impulse from state 1 to 2 equal to L2. And this method is simply energy method. Total energy would be conserved if force is conservative force, and we do know the work done from state 1 to 2 induce change of kinetic energy. Okay, things like that. So it's rather easy to say verbally, but it's not easy to apply those methods for the given problem. That's why we need a lot of practice, right? Suppose you have 3 tools. Without drilling the use of tools, you cannot use the tools in the appropriate way. That's quite obvious. Okay? So let's go back to the problem we handled the last lecture to see whether or not we are very familiar with first selecting those methods, and second, the efficient and the correct way to apply the selected method to the given problem. So again, we have a ball that is attached to massless bar, but it is rigid, very strange. Okay, this is A, and this one has mass ma, and this one has mass B, and this one was suddenly applied velocity v0. Therefore, we have momentum ma v0 at state 1 on frictionless table. Okay, on frictionless table, here is 2 ball, and we suddenly applied the velocity v0 on mass ma. Okay, And then we would like to know what's going to happen at state 2. Okay. MA. This linear momentum of mass A would be changed. So I call this is VA, and this mass would experience linear momentum that I can write MBVB. And here I have to write or draw impulse from state 1 to 2, what it could be. Okay, here mass, small mass. If there is a friction, this term would not be 0, but because there is no friction, okay, of course there is the force due to the presence of gravity in that direction, but that direction we do not have interest at all. So this is 0 because no friction. Therefore, we can say first which method we would like to select: star, moon, sun. Which one? Anybody can say? For this given problem, which one you would like to select? Minu? Which one you would like to select from those 3 possible method or tool? Because this involves mv and all velocity, therefore it's not likely the method which we want to select, right? Minu, what about this one? This involves velocity and the impulse. And this problem involves what? Velocity and impulse, but impulse is 0 because there is no friction. So, Minu, you want to select this one? This one? No answer? I will give you 2 seconds. We cannot wait 10 minutes. Oh, which one and which one? Why? Because you said you think the second and third method must be used to solve this problem. There must be some reason, right? What is your reason? Because no friction, therefore energy must be conserved. Okay. He said because no friction, energy has to be conserved. Oh, that's good. Okay. And why we can use the moon? Okay. So which method you would like to apply in the beginning? Okay, this one? Okay, let's start this one.